So we will be creating our class here. We're going to call this class employee, no public static void main, finish. Private integer ID, private string name. You can press and hold control spacebar, press and hold control and hit spacebar. You get this, you double click on it, and you have a constructor, the default constructor. Now, click on the source menu and click on generate constructor using fields. Generate constructor using fields, and then click OK, and then we have a constructor. Get rid of the super for now. We do not need a super. Now the first constructor will now call the second constructor with some default information. So anytime you call the default constructor, an employee gets an employee number 101 and gets an employee name Sadia. And we're going to now make a statement here. Sys out. Visiting overloaded constructor of employee class. Now generate the getters and setters. Go to source, generate getters and setters. Select all, click OK, and here you go. Now let's create the child class, which will be a slightly different experience for you guys for now. So we're going to have here employee with territory. Do not hit finish, okay? You see superclass. Superclass is another word used for a parent class or a base class, as child class is called a child class, derived class, subclass. Those are the words used for child class. So in the superclass, use type employee. In superclass, type employee. Do not check the public static void main and hit finish. And notice it automatically adds the word extends for you. Private, integer, territory ID. I'm creating a default constructor. Then I'm creating an overloaded constructor. And I'll be calling the overloaded constructor with a territory ID. Okay, do not create getters and setters yet. I will show you another way to create a getter and setter.
Well, thank you. I'm caught up.
Okay. Now, the quicker way than what you have right now is to hover over territory ID and click create getter and setter. This is the quickest way if you have only one property or one property for which you want to generate getters and setters. So it just gives you a dialog box and click OK. So that saves you having to click 4 times. It's just 2 clicks away, a little bit faster. Okay, everybody caught up so far? Okay. Now let's create a new class called demo mterr with a public static void main. So I would like to first create an instance of employee type, just a simple instance. That's about it. Because the empty constructor calls the overloaded constructor, which displays the output before it assigns the values, right? So That's why you will get one output, one line of output, which will be that visiting overloaded constructor. So that is to show you that even you are calling the default, it is still going to overload it. Before you run the code again, how many lines of output will you get because of line 7?
It was 2.
2 lines. Did everybody see 2 lines because of line 7? And what does that tell you? That tells you that whenever you call the constructor of the child, the first thing it does, it calls the constructor of the parent. That is why, since it calls the constructor of the parent before it completes his body, that is why you see visiting parent comes before visiting child. So what happens is the default constructor employee with territory gets called. It forwards this particular call to employee default constructor, which forwards the call to employee overloaded constructor, which displays visiting overloaded constructor. Then the call comes back to employee with territory, which then calls employee with territory. Right? And then it says overload constructor, employee with territory. Now if I type emp dot, how many getters do you see in the list?
Three.
3. Where's the first getter coming from? It tells you in the grayed out the name of the class in the same line. Get class is coming from object. So how can I see items from the object? That goes back to the initial chapters. We learned that every class is a child of object. You write it or you don't. That's how you get access to all these methods. If you start scrolling down the list, get class is not the only method from object. You have notify all, toString, wait, an overloaded wait. All of those methods are coming from the parent class object. Okay, so let's change this to empt1 dot. Now, how many gets do you see? 4?
Yes, 4.
Yep. So you are looking at the local get, which is get territory ID. You are looking at the 2 getters from the parent and 1 getter from the grandparent. Okay. Now, dot set. I'm changing the ID to 123. I'm changing the name Carl. And I'm changing the territory ID to 4567. I'm running a test here. Employee name and then employee with territory name, just so that you can see the difference, that employee's name will still be Sadia, but employee with territory's name will be Carl because we changed it. Let me do a blank line right here in the test. Now, let's go back to employee with territory. Let's say employee with territory constructor would not like to settle down for the defaults, which are 101 and Sadia. rather is interested in calling the overloaded method and would like to set its own defaults, because those are the defaults for employee. So it says, okay, I want to set my own defaults. So this is how you will take care of that. A child can call the parent constructor with the word super function call. Just like this is for local constructor calls, super is for the parent constructor call. But if I leave it like this, like on line 10, it will call the default constructor in the parent. But if I say I want to call the overloaded one, I want the default ID to be 1004, and I want the default name instead of Sadia to be Maria. So once I make this change, when you run it, you still see Carl and Sadia, right? Maria is nowhere to be found. The reason is Maria was generated, but we overrode it with Carl. So we're going to fix that so that you can also see Maria as well as Carl. But first make this change. That this is how a child constructor can call overloaded parent constructor, because the other one, it just automatically calls. The default one is automatically called, but this is how you can call the parent constructor, overloaded parent constructor. So basically, when employee with territory gets called, it doesn't call the parent constructor right away. Because of this, it forwards the call to the overloaded constructor, which will call the default parent constructor if no super statement exists. If a super statement exists, then it calls that constructor which matches the super call. Okay, everybody with me so far? Did you run it to make sure that you are getting the same output as before? Okay, now let's go back to employee with territory. And all I would like to do here is that I would like to grab line number 17, copy it, and paste it before I change anything. Okay, so let me go use blank lines. Blank line before it, so that you can now see that employee with the territory is Maria, then 2 lines down it changes to Carl. So I showed you before and after. So now let's go back to employee class and let's create an auxiliary method, public void display. Employee ID, employee name, so I'm creating a method which will display the ID and name instead of me having to call getters. It'll be much faster to just call display and I'm going to do the job for me.
Yep.
Okay. Now let's go back to demp territory, which is the demo one that we created. Okay, so in this class, we will now make a call calling display. So employee with territory can also call the display method because it's a public method from the parent, so it can call it without a problem. So now run the program and you will see that the employee with territory can call and display the information. And employee can also call and display the information. So they both can do that. And it does work for each one of them in accordance with the method, with the object. So if employee calls it, it displays employee's values. If employee with territory object calls it, it displays that object's values. Now comes the question that employee with territory would also like to see the territory ID. However, the problem is the display method in the parent cannot see the territory ID because that's a child property. Child property is not visible to the parent, but parent properties can be accessed by the child through the getters. So child, to overcome this problem, says, I will going to write my own display property, public void display, so I can display the territory myself, because my parent can't do that. So employee territory ID is, and then it displays the territory ID. Now, when you go back to demp emp terr and run it, it will do one thing which you were not expecting. It displays the employee territory ID only for the territory employee, because when territory employee calls display method, it will call its local display method, which is now overriding the one in the parent. As I explained you earlier today, that overriding happens when a child has an exact same copy of a method as a parent. So they both have an exact display with the same parameter set, which is no parameter. Therefore, the one in the parent is blocked by the one in the child. The parent instance can call the parent one. The child instance can only call the child one. So here comes the question, then how can child still call the one in the parent and also call its own? So for that solution, you have to go back to the child. And within the display of the child, you have to take help from a keyword super.display. This will call the overridden method in the parent. So therefore, Java developers write this annotation, even though it's not required, to show that this is an overridden method at override. On line 22, this override annotation shows that this is an overridden method. In C#, you have to write the word overrides, but not in Java. Java doesn't have any keyword overrides. So as I told you, there are some minor differences between the two languages that you're learning, but the concepts are same. So now when you make that call and rerun the program, you will see that employee with the territory first calls the display method in the parent to display the ID and the name, and then displays the territory ID. Okay, now let's go back to the parent employee, and we will declare a protected entity in employee. Protected integer workplace ID equals to, and let me create a constant final. Now this is protected. So protected means the child can access it as well as the parent can access it. Any method in the child can access it. Any method in the parent can access it, no problem, because it's protected. Now go to employee with territory.java, and in the display method right here, workplace ID, and now I will just refer to workplace, workplace ID. And notice it automatically understood it, even though it's not in the local class. It did not complain about it. That means it can see it. The one in the child, so I'm in the display method in the child, it can see the workplace ID constant from the parent because it's protected. And just to demonstrate this to you, if I go back to employee and make this private, the moment I do that, notice the employee with territory errors out and it cannot see workplace ID anymore. It says change the visibility to protected. It just gives you one of those suggestions. So if you click on it, it automatically replaces it to protected. And as you save the changes, it fixes the problem. So just to show you that how intelligently it can help you answer some of the questions if you ever run into that problem. Now rerun, and you'll be able to see that it displays workplace ID after ID and name and before the territory ID. Okay, so far so good, everybody? Okay, now, can all methods be overridden? And the answer is no. What kind of methods cannot be overridden? First of all, you cannot override static methods. If a method is static, you cannot override it. You guys remember the keyword final, right? It's used for constant, right? We just used it. But the keyword final is also used with a class. So for example, if I go to the employee class and say public final class employee, the moment I do that, employee with territory starts giving me an error. Why? Because a final class can never become parent. It says you have an error because employee with territory cannot become a child of a final class. So I'm going to just use the suggestion to remove the keyword final and save the changes. So what does the word final means? The final means for a class, it is the final class. It cannot become a parent of any class. So if you want to create a class that you can let people use it, but nobody can inherit from it, you're going to create it as a final class. So the final class is uninheritable, so are all the methods in the final class are uninheritable. And since they are not inheritable, you cannot overwrite them. Simple as that. Okay, so those are the items that you cannot override.